Hello everybody, welcome to Mad over MATLAB tutorials. This is Tanmay and this is the third part of a series of tutorials on graphics in MATLAB. And in this tutorial we will continue with two-dimensional plots, and in two-dimensional plots we will discuss what are field plots. Field plots are also called as vector field plots. So this is the definition. Vector field plots are mainly used to plot the velocity vectors at different positions. So this is how a field plot looks like. So as the definition says, vector field plots are used to plot velocity vectors. So these are your velocity vectors at different positions. These are the different positions, the points. Now let us see how to plot this field. First, you need to create a mesh grid using this syntax. I have already discussed what a mesh grid is in my previous tutorials. The mesh grid command creates a grid of points on which you can plot whatever figures you want. Now when you write this syntax, what happens is this argument serves as the x coordinates and this argument serves as the y coordinates. So the elements of this vector are assigned to x on the left hand side and the elements of this vector are assigned to y on the left hand side. So let us see what happens when you execute this statement. So I have executed this statement. What I have got in the workspace are two different arrays. One is the x array and the other is the y array. So let us open them to see what they contain. So the x array contains points starting from -5 to +5 in every row, and the y array is a transposed form of the x array. So when you combine these two arrays, you will get a set of points with which you will construct the grid that you want. Let us combine these 2 points or these 2 coordinates. The first is -5 in the x array and -5 in the y array. If you combine this, you will get a point -5, -5, which lies here. Now let us take any random point. Let us say we want this point. So this is -4, which lies on the 5th column and 2nd row of the y matrix, and the corresponding point or the corresponding coordinate in the x matrix is -1. So the point that you get is -1, -4, which lies somewhere here. Yes. So in this way you can get all the points in the grid that you have formed. Next, let us move on to the components of the velocity vectors that you want to plot. Now these vectors here are resolved in two orthogonal components along these two axes. The first is the u component and the second is the v component. Now this u component can be positive or negative, and even the v component can be positive or negative. Now if you see this vector, it has a positive u component and a negative v component. This is a result of these two statements. I have equated the u component to -x and the v component to y. So in order to get the u and v components at any point, you need to substitute the coordinates of the position where they lie. Now in this case, this vector lies at -3, -3. So if you want to get the u and v components, you just need to put these coordinates where you have written these two statements. So as your x is -3, your u will be minus into -3, that is +3, and your v will be -3. So your u and v are 3 and -3 respectively, which means that your u is positive and your v is negative. That's why you have got this vector in the fourth quadrant. Similarly, you can get the u and v components of any other vector in this field plot. Now if you see the origin, it has no vector. This is because when you put x and y 0, your u and v components will be 0, which means that your resultant vector will be 0 here. And finally, to plot these vectors, you need to use this keyword quiver, and in that you need to give the x and y vectors as the first two arguments, followed by the u and v vectors, or the u and v components of the velocity vector. So as you can see, we have got the same plot which we just now studied in our presentation. So that's it for this tutorial. In the next part, we will begin with three-dimensional plots. So till then, goodbye and take care.